Good morning, students. Yesterday we have studied about decomposition and combination reaction. Now today we are going to start with single displacement and double displacement reaction. So what do we mean by single displacement reaction? So in this reaction what happens over there is a salt solution and an element reacts with each other. One of the element replaces another element from salt solution and you get another salt solution. So as per this we can define single displacement reaction as a chemical change in which a highly active element, it may be metal or non-metal, replaces the less reactive element, that is metal or non-metal, from its salt solution. Remember, from its salt solution. So here we see that there is an element A salt solution BC. In this what happens? A will replace B from its salt solution to form a new salt, that is AC, and you will get element B. Same reaction is written over here. As said above, it replaces a metal or a non-metal. The same thing has been shown over here. Element which is higher in the reactivity series. What is reactivity series? It's a series in which metals or non-metals, ions or cations are arranged as per their reactivity. More reactive elements are arranged up while less reactive elements are arranged down. Okay, this reactivity series I am going to show you, but in more detail we will be studying it in third chapter, that is metals and non-metal. So a highly reactive element, it may be metal. Metals are called as electropositive elements, while non-metals are called as electronegative elements. So elements which is higher in reactivity series displaces those elements which are present below in reactivity series. More electropositive elements displaces less electropositive elements. Similarly, more electronegative element displaces less electronegative element. Let us see this with some examples. So here we have an example. Iron is more reactive than copper. So what we do, we take copper sulfate solution in a test tube. Copper sulfate is a solid. We are taking its solution in a test tube, and you can take a piece of nail or some iron fillings and put it in copper sulfate solution. As you insert iron into copper sulfate, it changes into iron sulfate and copper. So here what is happening? Iron is replacing copper, and you get iron sulfate and copper. Similarly, in second reaction what happens? Zinc reacts with hydrochloric acid. Now here you can see zinc is an element, hydrochloric acid. What happens? Zinc replaces hydrogen from its salt solution. You will get zinc chloride plus hydrogen gas. So these two reactions we are going to see by a video. Okay.
Procedure. Follow these steps to perform the experiment. Take about 10 ml, about half the test tube of copper sulfate solution in a test tube and place it on a test tube stand. Place gently a clean iron nail in the copper sulfate solution in the test tube and allow it to stand for about 10 to 20 minutes. Observe change in the color of the solution. Take out the iron nail with reddish brown deposit with the help of forceps. Examine the deposit on the nail and surface of the nail after scraping the deposit. Record your observations. Observations. Nature or color. Observation before the experiment, after the experiment. Iron nail color, grey in color. Reddish brown deposit on the surface of the nail. Surface is smooth surface. Surface of the nail is found corroded. Copper sulfate solution, blue, becomes light green. In this experiment, new substances are formed. The properties such as color, chemical nature, etc. of the new substances formed are different from those of the reactants. The test tube gets warmer during the change. It is not possible to get back iron and copper sulfate solution by any simple physical method, that is, this change is irreversible. Conclusions. The process studied in this experiment is a chemical change. Here iron displaces copper from copper sulfate solution. Precautions. Iron nail should be clean and free from any oil or grease on its surface. Do not disturb the test tube during the experiment.
Now, as I told you that we are going to see the reactivity series. So here is reactive series of metals. Now you can see here potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold. They are present in a series. Upper metals are more reactive, lower metals are less reactive. What it means? Suppose if I take a salt solution of sodium and I use potassium, what will happen? Potassium will replace sodium. Similarly, sodium can replace calcium, calcium can replace magnesium, or sodium can replace aluminium. So more reactive metal will replace less reactive metal. Let us see again this with some examples. Now for an example, if I take magnesium, if I react it with copper sulfate, as per the reactivity series, magnesium is more reactive than copper. So what will happen? Magnesium will replace copper. And as magnesium replaces copper, you are going to get magnesium sulfate plus copper. Similarly, if you take another element over there, like I can take copper sulfate, react it with aluminium. Again, as per reactivity series, aluminium is more reactive than copper. What will happen? I will get aluminium sulfate plus I will get copper. I can use again iron oxide and I can react it with aluminium. Aluminium is more reactive than iron. So what will happen over here is you will get aluminium oxide plus iron. So in this reaction, a more reactive metal is displacing less reactive metal from its solid solution. Generally, this type of reactions are again exothermic in nature. Remember I told you yesterday what do you mean by exothermic reaction? The reaction in which heat is evolved. When I speak about this reaction, aluminium reacting with iron oxide, it is called as thermite welding. Railway tracks are joined with the help of this reaction. What they do? They take some powdered form iron oxide in a container and to that they add little amount of aluminium. Now aluminium starts reacting with iron oxide and it is so exothermic, highly heat is evolved that you get iron in molten form. This reaction, iron you get in molten form, and this iron is placed between two tracks and then joined. So this process is also called as thermite welding.
Thermite is a pyrotechnic composition usually consisting of a metal powder and a metal oxide. It creates extremely high temperatures in a very small area for a short period of time. I show how to make thermite using aluminum powder and iron oxide. The temperatures can be as high as 4,500 degrees Fahrenheit. Thermite is used for welding, metal cutting, science demonstrations, high temperature ignition, disabling military equipment, and other applications. I'm using the basic 3:1 ratio with 3 parts iron oxide and 1 part aluminum. I measure out 27 grams of iron oxide. Then I measure out 9 grams of aluminum powder. Mix the powders together until the color is consistent throughout. The finer the powders and the better they're mixed, the easier it will be to ignite and the faster the reaction will be. You can use sparklers or magnesium ribbon as a fuse. I fill the thermite into the container. Start your thermite experiments with a small amount at first until you understand how it behaves and if the ratio needs to be adjusted.
This is about single displacement reaction. Now we are going to see the next reaction, that is double displacement reaction. In case of double displacement reaction, when we speak about, then we spoke about single, now here we are speaking about double. Now in case of single displacement reaction, a element was replacing another element from its salt solution. Double displacement means the elements will exchange now. Like we can see here, we have taken two compounds A, B and C. What happens here is C, if you see in this case, D is taking place of B and B is taking place of D. So two elements are exchanging itself. Hence it is called as double displacement reaction. Double displacement reaction are also called as precipitation reaction. Like you can see here, the definition is a double displacement reaction is a type of chemical reaction where two compounds, how those compounds should be, both should be aqueous, both should be in liquid state, react, and the positive ions, which ions? Positive ions, and the negative ions of the two reactant replaces each other, forming two new compounds or product, is called as double displacement reaction. Double displacement reaction, as I have said, is also called as precipitation reaction. Why? That I am going to show you with an example. The first example. Take barium chloride in a test tube and to it add a little amount of sodium sulfate. As said in double displacement reaction, there is exchange of ions. So what will happen over here is sodium will take place of barium and barium will take place of sodium. So you will get sodium chloride and you will get barium sulfate. Barium sulfate you will get as white precipitate. Precipitate means a solid. Hence, it is also called as precipitation reaction. We are going to see this reaction by a video.
Take a small quantity of sodium sulfate solution in a boiling tube. Then, take a small quantity of barium chloride solution in another boiling tube. Pour the barium chloride solution taken in the boiling tube into the boiling tube containing sodium sulfate solution. On adding, a white precipitate of barium sulfate is formed in the boiling tube. This confirms the presence of sulfate ions in the solution. Now keep the contents of the boiling tube undisturbed for 10 minutes. After 10 minutes, we can see that the white precipitate in the test tube settles to the bottom of the test tube.
Okay, so in the above reaction you have seen that a solid was forming, hence it was called as precipitation. Which PPT was forming? White PPT. What it was? It was barium sulfate. Let us see another example over there, another reaction over there. Take little amount of sodium chloride solution in a test tube. To it add little amount of AgNO3, that is silver nitrate. On adding silver nitrate to NaCl, your solution will turn into white, and that white precipitate will be of silver chloride, while you will get sodium nitrate also. So in this reaction again you will see a white precipitate is forming. So again this is a type of double displacement or precipitation reaction in which sodium is replacing Ag, that is silver, silver is replacing sodium. Again, I will show you this through a video.
In the double displacement reaction of silver nitrate and sodium chloride, we have a solution of silver nitrate, which is colorless. We will add a solution of sodium chloride, which is also colorless. When the sodium chloride solution is added to the silver nitrate solution, a white precipitate, insoluble silver chloride, is formed.
Now, let us see the next reaction. When solution of lead nitrate is added to potassium iodide, lead nitrate is added to potassium iodide. So, in this reaction, again there will be the displacement, double displacement, that is lead will take position of potassium, potassium will come in place of lead, and you will get potassium nitrate plus lead iodide. Lead iodide is yellow in color, so you will get precipitate of yellow color. So here again you can see that a precipitation reaction, a double displacement has taken place. So double displacement, why it is called as precipitation reaction? Because in that a solid, a precipitate is forming. Again this reaction we are going to see through a video.
In the double displacement reaction of lead nitrate and potassium iodide, we have a colorless solution of lead nitrate. We'll add a colorless solution of potassium iodide. As the potassium iodide reacts with the lead nitrate, we get the formation of a bright yellow solid, which is lead iodide.
So, students, in today's class, we have studied about single displacement and double displacement reaction. In single displacement reaction, there is replacement of only a ion from its salt solution. While in double displacement reaction, there is exchange of ions between two aqueous or two salt solution. Remember, double displacement is also called as precipitation reaction. Precipitation why? Because a precipitate or solid is forming. That's all for today. Tomorrow we are going to study about oxidation and reduction, and also I am going to tell you about two important concepts, that is corrosion and rancidity. Thank you and have a nice day.